I want you to just take a second and imagine a scenario for me.
Okay, I'm listening.
Think about the absolute last time you were hunting for like a highly specific piece of information online.
Oh, that happens to me literally every day.
Right, exactly. So you open up your browser, you stare at that blinking cursor in the search bar, and you start typing.
Just hoping for the best.
Yeah, because for the last 20 years or so, the unwritten contract of the internet was basically that typing the exact, precise words of what you wanted was the absolute best way to get it.
Which makes sense. I mean, that's how we were taught to use it.
But I want you to imagine a world where typing the exact word might actually be the absolute worst way to find what you're looking for.
Wait, the worst way?
The worst. A reality where that exact string of text is, nothing more than a trap.
I mean, that feels incredibly counterintuitive.
It really does.
Because we've essentially been trained since, the late 90s to treat that search bar as a literal command line interface.
Right. Type words, get results.
Exactly. The assumption has always been so simple. You put a word in, and a database will spit out a document that has that exact sequence of characters printed on it somewhere.
Which is exactly how we all learn to use the web. But today, we are going on a journey to explore how the internet has fundamentally shifted beneath our feet.
And it is a massive shift.
Huge. The entire digital ecosystem is moving away from a web of just matching characters and evolving into a web that actually understands meaning.
Yeah, that distinction is crucial. Matching characters versus understanding meaning.
So to guide us on this deep dive today, we are pulling from a truly fascinating source.
It really is.
It's a comprehensive piece of writing by Alexander Rodriguez Silva, and this expert manages to blend two seemingly incompatible worlds.
I was so surprised by this pairing when I read it.
Right. He takes the highly technical, ultra-modern landscape of SEO, search engine optimization, and fuses it with the centuries-old, meticulous discipline of library and information science.
And the synthesis he achieves there is just brilliant.
It blew my mind.
Because he takes us from the foundational theories of human linguistics all the way through to the practical, cutting-edge architecture of digital data.
Right. It's not just a how-to guide.
Exactly. What makes this so compelling is that we aren't just reading a dry technical manual about how, Google search algorithm gets updated.
Nobody wants to read that.
Right. We are looking at a profound mapping of how human knowledge is structured, how meaning is actually negotiated, and ultimately how information is retrieved in a profoundly noisy digital age.
And it is so noisy out there. So our mission today is to unpack this entire landscape for you.
There's a lot of ground to cover.
There is. We'll explore why the traditional keyword is effectively a relic of the past, killed off by the sheer chaotic complexity of human language.
May it rest in peace.
Seriously. Then we'll define a concept that sounds intensely academic but actually dictates your everyday life, the semantic field.
Oh, I love the semantic field concept.
It's so good. We'll also see how structural tools developed by librarians long before the invention of the microchip are basically rescuing modern digital architecture today.
Librarians really are the unsung heroes here.
Always. Then we're going to tear down a highly popular but fundamentally flawed digital marketing strategy known as the topic cluster.
That part gets a bit spicy.
Oh, it does. And finally, we'll uncover how true contextual intelligence is the only legitimate path to establishing authority online.
Because when you finally grasp the scale of this shift, you'll see it provides an incredible advantage.
For everyone, really.
Yeah. Whether you are architecting content for a massive enterprise, organizing data for your own small business, or frankly, just trying to navigate the web as a user without drowning in irrelevant garbage.
Which is all of us.
Right. Understanding this underlying matrix changes how you interact with every digital space.
So let's just start with the elephant in the room, the death of the keyword.
It's a big claim.
It is. Because for a long time, optimizing anything for the web, whether you were writing a local baking blog or building a multinational corporate site, it was entirely reduced to this relentless hunt for exact terms.
Yeah, the source points out that historically we treated keywords as these atomic units.
Atomic units meaning what?
Meaning they were totally isolated, completely devoid of their surrounding neighborhood, just a word floating in space.
And people still do this.
Oh, absolutely. The author makes a specific point to note that a vast number of professionals still operate this way today. They treat a web page as just a container for specific text strings.
Like a bucket you just throw words into?
Exactly. But he argues this is fundamentally insufficient for the modern web. And I want to be clear, this isn't merely an opinion or a philosophical stance from the author.
Right, this is baked into the tech now.
Yes, it is a reality forced by the hard mathematical evolution of search algorithms.
How so?
Well, we have moved from early information retrieval systems that literally just scanned a document's index for matching ASCII characters,
The old days.
right, to monumental leaps in natural language processing. Search engines have stopped just reading text. They are actively attempting to comprehend it.
Okay, I actually need to push back on this right away.
Go for it.
Because comprehend is a very strong word to use for a machine.
It is, yeah.
I mean, lexical search, which is matching the exact text string, it worked perfectly fine for 2 decades.
For the most part, sure.
Like, if I type the word apple because I want to buy an apple, the system giving me pages with the word apple on it seems like the most logical, efficient system possible.
Right, on the surface.
So why are we overcomplicating this? Why is lexical search suddenly treated like a villain?
Well, your Apple example assumes the volume of information on the internet has remained static, which we know definitely isn't true.
Okay, fair point. It's gotten a lot bigger.
Exponentially bigger.
Mm-hmm.
Lexical matching works brilliantly when you are searching a database of, say, 1,000 documents.
Jeez.
But when you are searching an index of hundreds of billions of pages, lexical search completely collapses under the weight of 2 things: synonymy and polysemy.
Okay, let's break those terms down for the listener.
Sure. So synonymy is when different words mean the exact same thing.
Like car and automobile.
Exactly. Lexical search forces the user to guess the exact term the author used. If you type car, but the article says automobile, you miss it.
Oh, right. You get penalized for using the wrong synonym.
Yeah. And polysemy is the reverse problem. It's when the same word means different things. Your Apple example is actually perfect for this.
Because it could be a bunch of different things.
Exactly. You type Apple into that search bar. Are you looking for a local farm stand? Are you looking for an iPhone retailer? Or are you looking for the Beatles record label?
Oh, wow.
In a purely lexical system, the machine has absolutely no idea. It just returns a massive pile of documents containing those 5 letters, A-P-P-L-E.
And then the user is just left to sort through all that noise.
Yeah, exactly. It's exhausting.
So, because the internet grew so incredibly massive, the sheer volume of noise made exact match searching useless.
Completely useless.
The system had to evolve to figure out what we actually meant, not just what we typed.
Right.
And the source goes deep into the linguistic theory behind why this is so difficult for a machine. He draws a fascinating line between 2 concepts I honestly always thought were completely interchangeable.
Tongue and language.
Yes, tongue and language. Can you explain that?
Yeah, this is a crucial distinction borrowed from deep linguistic theory. Think of a tongue as a specific, localized code used by a specific community.
Okay, so like Portuguese or French or English or Mandarin.
Precisely. Those are tongues. They have documented rules, vocabulary, syntax, dictionaries.
Things you can program into a computer pretty easily.
Exactly. But language is something much more profound. Language is a universal, symbolic human faculty.
Meaning what, exactly?
It is the higher psychological function that allows us to interact socially and literally construct our reality through symbolic representation.
Okay, let me see if I'm understanding this. So, language is the underlying human need and like biological ability to symbolize things.
Yes.
While English or Portuguese is just the specific flavor of software code we use to execute it.
That is a highly accurate way to visualize it. I like that analogy.
Well, thanks.
And the author highlights that automated systems, including the most advanced search algorithms in the world, have historically had an enormous struggle with this symbolic nature of human language.
Because it's so messy.
Very messy. Because the individual characteristics of language are entirely arbitrary and conventional.
Meaning there is no natural physical law in the universe that dictates the letters D-O-G must represent a furry, 4-legged pet.
Exactly. It only means that because of a subconscious, unspoken agreement among English speakers.
The word itself is just an empty vessel.
Yes. We pour the meaning into it.
Yeah.
And the source breaks down the theoretical functions of this language to show just how incredibly complex this gets for a computer.
Because it's not just about naming things.
No, language isn't just about pointing at an object and giving it a label. It has multiple functions. For instance, it has a referential function.
Which is what?
That's transmitting raw data or facts.
Yeah.
The sky is blue, the dog is big.
Okay, simple enough.
But it also has an emotive function.
Right. Expressing feelings, attitudes, nuances, like, I love that dog.
Exactly. And then It has a phatic function.
The phatic function. This one confused me at first. It's basically testing the communication channel itself, right?
Oh, okay.
Like when you pick up a phone and say, hello, you aren't actually greeting anyone yet. You're literally just sending a verbal ping to see if the line is open.
Or saying nice weather we're having in an awkward elevator ride.
Right, you aren't actually transmitting meteorological data.
No, you are establishing a social connection. You're filling silence.
Okay, so now imagine a machine trying to parse a document filled with referential, emotive, and phatic functions, all using arbitrary symbols.
It sounds like a total nightmare for a literal-minded computer.
It really does. I mean, it sounds like we used to treat the internet like a giant dumb game of Go Fish.
Go fish? How so?
You know, you ask the server, hey, do you have any pages with the exact word jaguar?
And the server just hands you every single card with those letters printed on it.
Exactly. Here's the car, here's the animal, here's the sports team. But now it's more like a therapist trying to understand what we really mean.
I like that.
The system has to look at the query and ask, okay, when you say jaguar, are you feeling the emotive excitement of a luxury sports car? Or are you transmitting referential data about a South American jungle cat?
That Go fish era relied on the completely false assumption that words have fixed, unchangeable meanings regardless of context.
Right.
But to solve the polysemy problem,
Yeah.
the Jaguar or the Apple problem search engines had to develop mechanisms to essentially read the room.
Read the room. I like that phrase.
Yeah. And this is where massive models like BERT come into play.
Okay, let's talk about the mechanics of that. Because people in our industry throw around acronyms like BERT and LAMDA constantly without ever really explaining what they actually do.
It's true. It becomes jargon very quickly.
So how does a system actually transition from just matching text to reading the room?
Let's take BERT as the prime example. It stands for Bidirectional Encoder Representations from Transformers.
Say that 10 times fast.
I'd rather not.
Yeah.
But before BERT, natural language processing models generally read text in only one direction.
Like left to right.
Exactly. Or right to left, depending on the language.
Mm-hmm.
They evaluated a word based solely on the words that came immediately before it.
That seems very limiting.
It was. But BERT is bidirectional. It looks at the entire sentence all at once.
All at once.
Yeah. It uses an attention mechanism to assign a mathematical weight to a word based on all the other words surrounding it.
So it's looking at the entire neighborhood, not just the front yard.
It is entirely focused on the neighborhood.
Okay, give me an example of how that changes things.
Let's go back to the word bank. If the model sees the word bank, and then 3 words later it sees the word river, the bidirectional attention mechanism mathematically shifts the definition of bank away from finance and toward geography.
Oh, wow.
Right. It converts these concepts into vectors, essentially numbers in a multidimensional space, so the algorithm can mathematically calculate the distance between concepts.
Okay, that mathematical proximity, that idea of mapping the neighborhood brings us directly to the core solution the author presents.
Yes, the big reveal.
Right. If human language is this messy, arbitrary, polysemic nightmare, the way we give the machine a map is through the concept of the semantic field.
The semantic field, it's foundational.
Let's define what a semantic field actually is because the source relies so heavily on this.
Absolutely. So, in linguistic terms, semantics is the system that interacts with human thought to explain the meaning of messages. A semantic field, specifically, is a set of words united by meaning. It is the structural framework that allows a system to work with the various meanings a single word can present, depending entirely on its context.
It's so tempting to just think of this as a list of synonyms, though.
That's the trap a lot of marketers fall into.
But it's much bigger than that, right?
Vastly bigger. Synonyms are just equivalent terms. A semantic field encompasses all the related concepts, the attributes, the entities that give a word its specific identity in a given scenario.
Okay, the author uses a classic example to illustrate this, using the Portuguese word banco, which translates directly to bank.
Yes. Think about that single isolated word for a second, bank.
Okay, if you just say bank to me with zero other context, my mind immediately goes to a financial institution. You know, vaults, tellers, ATMs, bad interest rates.
Right, that's your default semantic field. But what if we change the observer?
What do you mean?
If you are a database architect, your semantic field for bank immediately pulls in totally different words.
Like data, servers, SQL, cloud storage.
Exactly. If you are a landscape architect, your semantic field for bank includes a park bench, wood, seating, or perhaps a riverbank, soil and erosion.
Oh, because banco in Portuguese can also mean a physical bench you sit on.
Yes, exactly.
Okay, that makes sense.
And if you are a doctor in a hospital, your semantic field for bank immediately triggers blood, plasma, donation, and typo negative.
This is where it really clicks for me. Each one of those specific uses has its own totally unique gravitational pull of surrounding words.
Gravitational pull is a great way to describe it.
And the author emphasizes that context is the ultimate resolver of ambiguity.
It's the only way out of the trap. Without mapping out the general field and identifying the specific subfields, like, charting the mathematical distance between plasma and bank versus mortgage and bank, a search system is literally flying blind.
It will just generate that go fish noise we talked about.
Exactly. It'll just hand you every card it has. Now, the human brain processes these fields instinctively through what are called associative series.
Associative series,
Right.
okay?
Our neurological architecture naturally organizes information hierarchically and relationally. The text uses a biological classification example.
Oh, the cat example.
Yeah, think of a cat.
Right, so cat belongs to the category of feline, which belongs to the larger category of mammal.
Exactly. When you interact with a cat, your brain instantly and subconsciously lights up that entire associative series.
I don't even have to think about it.
No, you don't have to consciously remind yourself that a cat is a mammal. The semantic field is already active in your mind. The relationships are just hardwired.
Let's bring this down to earth for you, the listener, because you utilize semantic fields every single day to survive the chaos of your own life.
We all do.
Think about packing for a trip. You are staring into your closet. You own a pair of running shoes and a pair of track sneakers.
Okay.
Now, in a strict exact match keyword database, those are two totally different, unrelated strings of text. They share literally 0 characters in common.
RUNNING versus TRACK.
Right. But in your brain, they instantly snap together into a semantic field of, athletic footwear I need for my morning jog on vacation.
You instinctively group them by their functional meaning, not how they're spelled.
Exactly.
Or consider the incredible semantic processing you do when managing your inbox.
Oh, the email example is perfect. Let's do that one.
Sure. Let's say you receive an email with the word Java in the subject line.
Okay, Java.
If the surrounding words in the little preview snippet are receipt, latte, grande, and Starbucks, what does your brain do?
My brain instantly files that under the semantic field of coffee shop expenses. I might not even open it. I just archive it.
Exactly. But if the email with the word Java also contains the words update, plugins, security, and error code.
Oh, then my brain instantly files it under annoying software issues that I probably have to deal with today.
Right. You didn't consult a dictionary definition of the word Java. The contextual words hovering around it resolve the ambiguity in a fraction of a second.
That is the immense power of the semantic field in action. It is an instinctual, rapid-fire human categorization process that basically keeps us from being paralyzed by ambiguity every second of the day.
It's survival.
But here is the massive challenge we face. Our brains do this effortlessly. It's basically magic meat hardware honed by millions of years of evolution.
Meat hardware, I like that.
How on earth do we teach a massive server farm in the desert to mimic this instinctual human categorization? Like, how do we take these invisible subconscious connections and make them explicit for, a Python script?
Well, the source makes a very profound argument here. To teach machines how to navigate the future, we actually have to look backward in time.
Backward.
Yes, we need established, rigorous structural artifacts to map these abstract concepts into machine-readable formats.
We can't just expect the AI to figure it out.
No, we cannot just expect the algorithm to feel it out or intuit it. And the people who've been engineering these structural artifacts for centuries are not Silicon Valley software developers.
Which is the twist of the century.
They are librarians.
I find this intersection completely fascinating. The idea that to fix the ultra-modern AI-driven internet, we have to borrow the blueprints from the local library.
The author posits that the collision between SEO and library and information science is the absolute best framework for creating indispensable knowledge with long-lasting results.
Because they've been doing it forever.
Exactly. Information professionals have been actively combating the problem of human language ambiguity for literally centuries.
It makes total sense when you think about it. A librarian in, say, 1950 had the exact same fundamental problem as the Google algorithm in 2026.
Yes. How do I make sure this user finds the exact right piece of information when they ask a highly vague, polysemic question?
And the tools they developed to solve that problem, specifically taxonomies, thesauri, and ontologies, are exactly what digital architects need to improve the organization of digital data today.
The source breaks down specific structural types used in information science to organize topics, moving from the simple to the highly complex.
Let's walk through these structures, because I think in the digital marketing world, people throw the word structure around without knowing what it actually means mechanically.
Oh, concept. So first we have linear structures.
Okay, linear.
These are essentially just subject lists. An A to Z alphabetical index at the back of a textbook is a linear structure.
It is functional, but it lacks depth.
Right. It doesn't tell you how A relates to B. It just says, here is A, here is B.
It's just a flat directory.
Exactly. Second, we move to hierarchical structures.
Okay.
These are taxonomies. This introduces the concept of subordination.
Subordination.
Yes, a parent topic encompasses child topics.
Yeah.
Go back to our biological example. Mammal is the parent, feline is the child, cat is the grandchild.
Oh, I see. It operates on a strict top-down inheritance model.
Yes, everything a mammal is, a feline inherently is.
It's a family tree of concepts. It gives you a sense of scale and inclusion.
Right.
But the world isn't strictly top-down, is it? Things are messier than that.
No, it isn't. And that is where the third type becomes absolutely critical. Relational structures.
Relational structure.
These are thesauri and ultimately ontologies.
Ontologies is a big word. What does that do?
These structures establish complex connections of equivalence and association. They map how things relate to each other, not just top-down, but laterally across totally different domains.
So they define how two things are connected, not just that they are connected.
Exactly.
Yeah.
Let's pause on the word topic for a second, because in the content creation space, we hear this constantly.
Oh my gosh, yes. Write about this topic. We need to cover that topic. It's used very casually.
And the author is highly critical of that casual usage. In information science, a topic is not just a loose label or some vague theme for a blog post.
What is it then?
It is a rigorous structural component. Its entire purpose is to take raw, chaotic data and process it into organized, accessible knowledge.
That sounds like serious work.
It is. The source explains that the core function of a topic is twofold. First, to delimit.
Delimit, meaning drawing a boundary.
Yes, aggressively choosing the scope of what is included and, equally importantly, what is intentionally excluded from the conversation.
Right.
Second, to hierarchize.
Which means grouping and naming things logically within the broader system we just talked about. So defining a topic precisely is basically the weapon against ambiguity.
It is the only weapon.
It ensures that every writer working on a project and every automated system crawling that project interprets the term with the exact same boundary.
The author points out that this rigorous organization by topics didn't just appear out of nowhere.
Right.
It evolved from the physical indexes of books to the card catalogs and vast library halls, all the way to today's sophisticated vector-based topic modeling systems in AI.
The medium changed, but the core mandate is the same.
Resolving ambiguity through structure. It remains identical.
And this is where classical library techniques like subject indexing become absolute superpowers online.
They really do.
The source mentions that proper subject indexing guarantees a document is findable regardless of the exact term the user types in.
Yes, findability is the ultimate goal.
This goes back to my closet example. If a website's underlying architecture is built on a relational structure that explicitly maps running shoe and track sneaker as equivalent entities within the exact same semantic domain, the system becomes vastly more resilient.
It doesn't punish the user for using a synonym.
Exactly.
Because the system is indexing the document by its subject, its core, true meaning, rather than the isolated text string. It recognizes the equivalence at the entity level.
Let me put an analogy on this to see if I have the mechanics right in my head.
Let's hear it.
The old keyword method was basically like dumping all of human knowledge into a giant pile of books in the middle of a dark room.
Okay, a bit chaotic.
And just hoping the user happens to trip over the right spine because they guessed the exact title.
That's pretty accurate.
But this library science approach, semantic architecture, is like building a beautifully curated, brightly lit museum exhibit.
Oh, I like that.
You provide a map at the entrance. You have placards explaining how the artifact in room A historically influenced the painting in room B. You are actively transforming raw text strings into a machine-processable web of knowledge.
That is a highly accurate visualization. You are engineering an environment where information pertinence is guaranteed.
Guaranteed.
And the nuance of meaning is preserved across the entire database, not just lost in a pile.
But here's where I get cynical.
Uh-oh.
If this is the gold standard, building these complex ontologies, mapping relational structures, rigorously delimiting topics, it sounds incredibly hard.
It is hard work.
It sounds like it requires deep intellectual labor. Yet, if you spend 5 minutes looking at digital marketing advice on YouTube or LinkedIn today, you are bombarded by gurus selling easy templates.
Just use this one trick to rank on page 1.
Exactly. And the biggest buzzword over the last few years has been the topic cluster. So if this library science approach is so foundational and difficult, how does it square with these easy marketing hacks?
Oh, it doesn't.
It does.
Not at all. And this raises an incredibly important tension in the text. The author does not hold back here.
He gets a little fiery, doesn't he?
He transitions into a highly academic yet very fierce critique of the modern digital marketing industry.
Yes. The source goes directly after the false prophet of the topic cluster and contrasts it with true knowledge engineering. It's fascinating to see someone call out the industry from the inside like that.
He identifies a severe conceptual confusion that is currently dominating the search market. The digital marketing industry has this notorious repetitive tendency to, as he puts it, rename what is already known.
Rename what is already known.
Yes. They take basic rudimentary principles of information organization, slap a trendy new marketing label on them, and sell them as massive technological breakthroughs or proprietary methodologies.
Buy my $500 course on the revolutionary topic cluster method.
Precisely the phenomena he is critiquing. When you look at these strategies through the rigorous lens of actual information science, topic clusters and the pursuit of so-called topical authority are exposed as mere operational tactics.
Or just tactics.
They are superficial structural habits. They are not the strategic true north of a semantic SEO project.
Okay, we need to do a deep dive comparing these two directly. Let's look at the mechanical clustering strategy versus a true semantic ontology.
Let's do it.
What exactly is the market defining as a topic cluster today, and why is the author tearing it down so aggressively?
The common market definition of a topic cluster usually involves creating a massive generalized main page, often called a pillar page.
Right, the pillar.
Let's say it's a 5,000-word guide to baking.
Okay, baking.
You then surround this pillar with smaller, highly specific satellite posts, one on chocolate chip cookies, one on sourdough starter, one on measuring flour.
Makes sense.
The quote-unquote strategy is simply to hyperlink all the satellite posts back to the pillar page and the pillar page out to the satellites.
Now, I have to play devil's advocate here.
Please do.
That sounds incredibly organized. It sounds logical to me. If I'm Google and I see a giant hub of baking links all pointing to each other, why wouldn't I reward that? Why is the author attacking this?
Well, the author isn't claiming that internal linking is inherently evil or harmful. Links are fine. What he is attacking is the illusion of depth.
The illusion of depth.
Yes. A mechanical topic cluster is a highly simplified, frankly basic application of thematic organization, something librarians mastered with card catalogs 100 years ago.
Right.
The danger lies in treating this mechanical hyperlinking as an innovative strategy. It reduces the deep intellectual work of tree meaning making into a rudimentary structural web of URLs.
It's treating the symptom instead of the underlying disease.
Yes. The primary danger of focusing excessively on clusters is that it inadvertently creates silos of content.
What silos?
It completely ignores the vast, messy interconnectivity of human knowledge. In a mechanical cluster, the baking cluster sits totally isolated from, say, the chemistry cluster.
Even though baking is literally chemistry.
Exactly. But in reality, a topic is not an isolated island with a few satellites orbiting it in the void. It is a node in a massive multidimensional graph.
So if I just mechanically link all my baking articles together, I am creating a silo. I'm just screaming at the search engine, look at my massive pile of URLs containing baking words.
You're just pointing at a pile.
But I'm not actually structurally explaining how the protein in flour relates to gluten development or how ambient temperature mathematically affects yeast fermentation.
You haven't defined the relationships. You've just drawn a line between two pages.
Wow.
In what the author calls the semantic workflow, a cluster is nothing more than a structural byproduct.
It just happens naturally.
Yes, it happens naturally as a result of good organization.
Yeah.
But the true goal, the actual strategy, is knowledge engineering and domain modeling.
Okay.
It is the creation of an ontology. You are mapping the actual entities and properties of a domain, defining their precise relationships, not just stringing web pages together with blue text.
This fundamentally shatters how most people view the concept of topical authority.
It completely reframes it.
Because the prevailing wisdom, right now, treats topical authority like a quota system. If I publish 100 articles about baking and link them all together, I will magically achieve topical authority and dominate the rankings.
The author dismantles that volume-based idea entirely. Topical authority isn't a video game achievement you unlock by hitting a word count KPI. You don't win the semantic web by just producing the most text.
Then what is the actual mechanism of authority if it isn't volume?
It is the natural consequence of exhaustive indexing and absolute semantic clarity. In information retrieval science, authority is inextricably linked to two specific metrics: precision and recall.
Let's break those down. Precision and recall.
Precision is the system's ability to deliver the exact, correct answer without any irrelevant noise.
Okay, no fluff.
Recall is the system's ability to find all the relevant instances of that answer within the database without missing any.
Okay, so precision is accuracy, recall is thoroughness.
Exactly. Topical authority, therefore, is about how hyper-competent your architecture is at delivering exactly what the user needs. It's about becoming a mathematically reliable reference node because your information is perfectly structured, mapped, and disambiguated.
Not just because you have a lot of URLs.
Correct.
So if we abandon these mechanical vanity clusters and move toward true interconnected knowledge graphs, it requires a massive shift in perspective.
Massive.
You aren't just a writer or a link builder anymore. You are an engineer of meaning. You have to build what the author calls contextual intelligence.
Which is the true differentiator. It is the only way to survive the transition to the modern digital landscape.
Let's dive deep into that, because this is where the theory hits reality. If we throw out the old keyword density tricks and we move past the superficial topic cluster silos, how does building contextual intelligence actually give a business or a creator a tangible advantage against their competitors?
Well, it upgrades your entire project from traditional SEO into a new paradigm the author calls the web of data.
The web of data.
He stresses that investing in this semantic infrastructure isn't just a technical SEO checklist. It is a foundational business strategy.
The text details some very specific practical applications for how this semantic approach works in the day-to-day operations of a project. Let's walk through these, starting with the concept of building entities. We mentioned entities earlier, but how do we build them?
When you map a semantic field properly, you are essentially categorizing the world. This makes it vastly easier for natural language processing algorithms to extract conceptual and named entities from your text.
Give me an example of an entity.
Entities are the specific people, places, organizations, abstract concepts, or events within your domain.
Okay.
Instead of just having the flat text string Eiffel Tower sitting on a page, you establish the entity of the Eiffel Tower.
And how does the machine know the difference between the text string and the entity? They look the same on the screen.
Because you surround it with a dense, unambiguous semantic field. You provide its coordinates, its height in meters, its construction date, and you explicitly define its relational edges to other entities like Paris, which is a location, or Gustave Eiffel, which is an architect.
Oh, I see.
This transforms a flat piece of text into a multidimensional, verifiable object in the database.
That makes total sense. You are handing the algorithm a 3D model instead of a Polaroid picture.
That's a great analogy.
Okay, the next practical application the author lists is thematic classification.
Right. By exhaustively covering all the terms, properties, and relationships within a semantic field and organizing them using those library science taxonomies we discussed, you send an undeniable signal of trust to search engines.
Trust is currency.
It is everything.
Yeah.
You aren't just loudly claiming you are an expert on a topic. Your underlying structural classification mathematically proves your authority on that subject. The machine can verify your depth.
It's like in high school algebra. The teacher doesn't just want the answer. They want you to show your work. Semantic architecture is showing your work to the algorithm. Now, the third application mentioned is semantic writing. I find this one fascinating because we've been talking about machines and algorithms this whole time, but this brings the human writer right back into the center of the mix.
Absolutely. It doesn't replace the human. When human writers thoroughly understand the semantic field they are operating within, it acts as an intellectual guardrail.
A guardrail.
It prevents them from wandering off topic, and it helps them naturally embed the necessary network of entities within the prose. This drastically reduces the chances of the content being ignored by search engines due to ambiguity.
So the writer isn't awkwardly stuffing keywords into a paragraph to hit a quota.
No, they are naturally weaving a coherent web of related concepts because they actually understand the domain.
It elevates the writing from SEO spam to actual subject matter expertise.
Exactly. And the final practical application is concept alignment.
Concept alignment, what does that look like?
This is where semantic SEO becomes a process of building transparent meaning. Concept alignment provides the explicit metadata that connects data for algorithms.
Connects it how?
It ensures that the specific concepts and jargon used internally by your business align perfectly with the universal concepts understood by the global search engine graph.
Okay, and to actually execute all of this, the author introduces a methodology he calls the FTS, the Semantic Workflow.
Yes, FTS.
It sounds like a rigorous step-by-step process for turning chaotic ideas into structured data.
It is a highly operationalized framework. The FTS relies on three main pillars to achieve this contextual intelligence. First, mapping key terms.
Which is the delimiting phase we talked about earlier.
Exactly. You must exhaustively identify the core concepts and boundaries of your specific domain. Second, creating knowledge graphs.
Okay, this is where we get technical.
This is where you move from theory to code. This involves consolidating the relationships between those terms using explicit semantic markup.
Let's talk about the mechanics of that markup, because the source specifically mentions schema.org. For the listener who isn't a developer, schema.org is basically the universal translator for search engines, right?
That's a fantastic way to put it. It is a standardized vocabulary of microdata.
Microdata.
When you look at a web page, you see formatting, bold text, big hitters, bullet points. But the machine just sees code. Schema allows you to wrap a piece of text in invisible code that tells the machine exactly what that text is.
So instead of Google having to guess that the random string of numbers at the bottom of the page is a phone number, you use schema to explicitly state property, telephone.
Exactly. You explicitly code the connections. You tell the machine, this text isn't just a name, it's the type, person who is the property, author of this type, article. You remove the burden of guessing from the algorithm entirely.
You eliminate the ambiguity.
100%. And the third pillar of the FTS workflow is the integration of semantic tools.
What kind of tools?
Advanced technologies that allow your system to learn from how users are actually searching out in the real world, identifying new synonymous relationships or emerging subtopics, and continuously feeding that new understanding back into your underlying knowledge structure to keep it dynamic.
It's a living system.
Yes.
So when we step back and look at this massive architectural effort, mapping semantic fields, building entities, structuring ontologies, writing schema code, why is this contextual intelligence the ultimate differentiator?
Why go through the trouble?
Right. Why should a business go through all this grueling intellectual labor instead of just buying a batch of cheap keyword articles like they did in 2015?
Because the entire trajectory of artificial intelligence demands structured information. Period.
I'm hungry for it.
As we move deeper into the era of large language models acting as answering engines rather than just traditional search engines, these AI systems need information that is explicitly structured so it can be confidently cited, synthesized, and comprehended.
If your data is just a messy, flat pile of exact match keywords, the AI cannot confidently trust it to generate an answer for a user.
Exactly. It will bypass your site entirely for a source that has explicitly mapped its facts.
The author makes a really beautiful point here, I thought.
Which part?
Where he says that by providing context and eliminating ambiguity, you aren't just doing technical SEO to appease web-crawling robots. You are engaged in something much more profound.
The bridge.
Yes, you are building a bridge of meaning between your organizational knowledge and the human user who desperately needs it.
A bridge of meaning. That is such a powerful way to frame it.
It really is. I mean, it is the fundamental difference between shouting a list of disjointed, chaotic facts into a crowded, noisy room versus sitting down quietly with someone, understanding their specific, nuanced problem, and handing them the exact, verified solution.
One is just noise that gets completely lost in the crowd.
And the other is indispensable, irreplaceable value.
And that is exactly why the author concludes that the future of the web is undeniably semantic.
It has to.
The digital entities, whether they are businesses, publishers, or independent creators, who embrace this rigorous library science approach, who put in the work to build true contextual intelligence, will be the only ones who thrive as algorithms continue their rapid evolution toward meaning.
Wow. Let's take a breath and recap this incredible, complex journey for you.
This is a long one.
We started by attending the long overdue funeral of the exact match keyword. We realized that human language, with its arbitrary symbols, its emotive nuances, and its rampant polysemy, is far too chaotic for simple text matching algorithms to handle at the scale of the modern internet.
We then explored the profound power of the semantic field to resolve that human ambiguity. We saw how systems map the neighborhood of words, mimicking the way your own brain instantly knows the difference between a hospital blood bank and a financial institution based purely on the contextual clues surrounding the word.
From there, we looked backward to move forward. We saw how centuries of rigorous library science linear lists, hierarchical taxonomies, and relational ontologies are the exact blueprints needed to bring order to digital chaos.
Ensuring that information is truly findable by subject, not just by spelling.
Exactly. We then dismantled the modern marketing myth of the topic cluster, revealing it as a highly superficial mechanical tactic that creates isolated silos compared to the deep, interconnected work of true knowledge engineering.
And finally, we saw how contextual intelligence, the painstaking process of building entities, aligning concepts, and explicitly coding connections with tools like schema, is the ultimate key to establishing digital authority in an AI-driven world.
Because whether you are architecting a massive enterprise database, writing specialized articles, or just trying to navigate the web as a consumer without drowning in irrelevant noise, understanding this invisible mathematical web of meaning gives you a massive advantage.
You are no longer just looking at the surface of the web.
You understand the deep architecture underneath.
You understand how meaning is negotiated.
But as we wrap up this deep dive, there's one highly provocative thought I want to leave you with.
Oh, lay it on me.
Something that builds on all the linguistic and technological theories we've explored today, but takes it a step further.
Okay.
We've established that the future of the web relies entirely on mapping the quote-unquote correct semantic meaning of human language.
Right.
But we also established early on that human language is highly subjective, deeply emotional, culturally biased, and ultimately arbitrary.
Very messy.
So the critical question becomes, who or what ultimately gets to decide which meanings are prioritized in the global knowledge graph?
That is the million-dollar question.
As artificial intelligence begins to structure our reality through these massive semantic ontologies, are we simply teaching the machine our nuanced, messy understanding of the world? Or, by forcing our data into its rigid structures, will the machine soon start teaching us its own?
Wow. That is a wild, slightly terrifying thought to chew on.
It really is. Thank you so much for joining us on this deep dive into the source material. We hope this fundamentally changed how you view that little blinking cursor in the search bar.
It certainly changed my view.
Keep questioning the systems around you, keep looking for the hidden structural connections in the information you consume, and remember the exact word you type might just be the very beginning of the meaning. See you next time.